Okay, for 1.5, we're going to be practicing graph analysis. So we're going to be using our graphing calculators. So first, let's talk about how to clear our calculators. You should be clearing them before and after you use a calculator each time in class. So first you'll hit second, and then plus 7, and then you'll arrow over to reset all, and then 1 and 2. And then not necessarily for today, but later when we get into trig and start working on angles and degrees, you'll need to make sure to put back in degree mode. So the mode won't affect what we're doing today, but it will later in the course. And the reset puts the default in radians. All right, so let's start by clearing our calculators. So second plus 7, and we're going to arrow over to all, 1, 2. All right, so again, just like we did that, we're going to go through kind of what we're doing on the calculator, and then we're going to practice it. So we're going to write down all the steps so that we know what they are. So for each function, we're going to sketch a function and then find each of the following. We're going to find the domain and range, which we'll find by looking at the degree and the leading coefficient. And then we'll find zeros on our calculator by hitting second, trace, and then option 2, 0. Okay, the intervals where a function is increasing, we can tell that by looking at it and knowing where some of these points are. So the increasing is when the graph is rising from left to right between the extrema. The function is decreasing when it's falling from left to right, also between extrema. It is constant when the x values on either side. It's constant for the x values on either side of a horizontal segment. So any part that's horizontal, the intervals would be the x values where it starts and stops the horizontal segment. Okay, a relative minimum can be found on the calculator by hitting second, trace, and then selecting number 3, minimum. A relative maximum can be found hitting second, trace, and then number 4, maximum. And then when you're asked to evaluate the function at given values, we're given the x, looking for y. You can hit second, trace, and then number 1, value. In order to use this one, the specified value, the specified x value, must be in the visible window. So you may need to make adjustments to your window if needed in order to use that function. All right, so we're going to do some examples. Anytime you're asked for like a relative minimum, maximum, intercepts, you're going to label them on your graph. All right, so we're going to start by graphing this function. So to graph a function, the function is like y equals, so we're going to go to y equals, and we're going to type in 2x, this x is right by the alpha, 2x raised to the third power, and then arrow over so that it takes it out of the exponent, minus 9x squared plus 5x minus 2. And then we can hit graph. So notice that on my graph, I can't quite see the minimum, like it goes off the graph. So to fix that, we're going to go to the window and we need to go further down. So I'm going to go to the window and I need to change my y minimum. We're not entirely sure how far down to go, so maybe let's try -30 and then hit graph again. All right, and now I'm able to see it. So -20 may have worked also, but I just picked a number bigger than negative, or smaller than -10. All right, so we're gonna sketch this on our papers. Okay, it should look pretty close to what you see on your screen. And then we're gonna label certain points. So we are gonna be asked for the domain and range, the zeros, increasing, decreasing, the minimums, the maximums, and then evaluating. So we'll label our zeros. The zeros are the x-intercepts where it crosses the x-axis. So x-intercept is also the same thing as the zeros. We have a relative max here. I didn't do a very good job of drawing that. It should have crossed. Maybe it really should go maybe more like that. Okay. And then we have a relative minimum here. Okay, it doesn't ask for the y-intercept, so I wouldn't necessarily have to label it, but I'm gonna do it for now so we can see, like, if we were asked for the y-intercept, it's the point where it crosses the y-axis. It would be right there. All right, so now let's use our calculator to find each one. So the first one is asking for the domain. So I can find this just by kind of looking at the graph. It's going to go from -infinity to the right to +infinity. So the domain is -infinity to infinity. And then B is the range. So bottom, -infinity to top, +infinity. Then it asks for the zeros. So the zeros right here where it crosses the x-axis. So we're going to grab our calculator and we're going to go to second trace, and number 2 allows us to calculate the zero. So we're going to hit number 2, and then the 0 is right here. So we're going to arrow over so that we get our cursor close to the 0. We still want to be to the left of it. So here, tracing from left to right, we're below the x-axis if we're still to the left. So we're going to hit enter, and then right bound we need to go to the right. So we're going to keep going further to the right and hit enter when we're to the right or above the 0, and then hit enter again. So my 0 is at 3.928, and then this is essentially 0. It's like 0.0000000000001. So it's 0. So my 0 is going to be 3.928. If it asks you for a 0, you're just going to write that number. But if it asks, if the wording is x-intercept, you're going to write it as an ordered pair. So a 0 is just the number, x-intercept is the ordered pair. All right, the next thing that they're asking us for is where it's increasing, decreasing, or 0. So I need to find the minimums and maximums first. So let's find that relative maximum. Second trace, maximum is number 4. So we're going to go close to the maximum. We need to be to the left of it, so hit enter. Go to the right of it, hit enter, and enter again. The maximum is at, this is H. So the maximum is at 0.310. Negative 1.255. And then we can do the same thing. We can find the relative minimum. Back to second trace. Minimum is number 3. Go to the left of the minimum, hit enter. Go over to the right of the minimum, hit enter, and then hit enter again. So the minimum is at 2.690, negative 14.745. All right, so this is helpful because I know where I'm starting and stopping my increasing and decreasing, where my turning points are, okay? So if I trace my graph, I start at negative infinity and I increase up to this point. Well, that x value is 0.310. So I'm going to increase from negative infinity to 0.310. And then I'm going to turn and I'm going to decrease from 0.310 to 2.690. So this is decreasing. And then I'm going to turn and I'm going to increase from 2.690 up to infinity. So go back up to increasing, union 2.690 to infinity. Okay. Constant, there are no intervals where it's constant, so just none. All right, and then evaluate f of negative 1, f of 0, f of 4. So this is where I'm given x and I'm looking for y. So I'm going to go back to second trace and I'm going to find the value. Value means you have the x value and you're looking for y. So number 1, if x is negative 1, y is negative 18. Do the same thing for the next one. Second trace, value. If the value is x equals 0, y equals negative 2. Okay, so we can see that here on our graph, the y-intercept is at 0, negative 2. And then one more second trace, number 1. If x is 4, y is 2. All right, let's do one more graph together. So we're going to go back to y equals. We're going to clear this, and now we're going to put in our new example. 3x raised to the 4th power plus x raised to the 3rd power minus 9x squared plus 4x minus 3. Hit graph. Okay, and I can see that graph pretty good, so I don't really need to adjust anything. We're going to sketch that on our papers. Okay, so I have zeros here and here, and I have a relative minimum here and a global minimum here, and then I have a relative maximum here. All right, so A asks us for the domain. So the domain, it continues to the left and to the right, so negative infinity to infinity. B is the range. So in order to know the range, I need to know what these values are. So how far down does it go, and then up to infinity. So I know that this part's going to be infinity. I need to figure out that lowest point. Well, how do I find that lowest point? Second trace. It's a minimum, so number 3. So we're going to go just to the left of that minimum, hit enter. Go over just to the right of the minimum, hit enter again. It's at negative 1.446, comma, negative 17.510. So the lowest y value is negative 17.510. All right, let's go ahead and put that in as our minimum here while we have it on our calculators. Okay, and we can go ahead and calculate the rest since we're doing that. Second trace, we can do the maximum next. Enter, go to the right, enter. So this global maximum is at 0.241. Negative 2.535. And then we can calculate that other minimum. Second trace, number 3 is minimum. Arrow over to the left, to the right of the minimum, enter. And this one is just a relative minimum. All right, so that will help us with our intervals that we're looking for here. oh, sorry, the range here should be a square bracket up to infinity because it does hit that minimum point. All right, so then my zeros, I can calculate those next. This one and this one. So second trace, number 2, 0. Let's go over to the left 0. We're going to go to the left of the 0, enter. Go to the right of the 0, enter, enter. Okay, that's 1, 0. And then calculate the other 0. Okay, the left of the 0 to the right of the 0, enter. Okay, notice I'm not putting these in parentheses as an ordered pair. These are two separate answers. If I asked for x-intercepts, you would put negative 2.134, comma 0, 1.441, comma 0. It would be two separate zeros, two separate ordered pairs. Okay, so no parentheses. I'm just listing two separate zeros. All right, then I'm looking for where the graph is increasing, decreasing, and constant. Well, right now I can go ahead and say it's not going to be constant. So we can go ahead and put none here because there are no places where it's constant. So let's trace it. We are decreasing from negative infinity to negative 1.446. So decreasing. And then I turn and I'm increasing from negative 1.446 to this maximum at 0.241. And then here I turn and I'm decreasing again from 0.241 to 0.955. And then I turn and I'm increasing from 0.955 up to infinity. All right, and then finally, evaluating. So we're given the x values, we're looking for y. So we can go to second trace, number 1, and when x is negative 2, y is negative 7. Again, second trace, number 1 value, when the value of x is 0, y is negative 3. And second trace, when the value of x is 1, y is negative 4. So notice on both of these, 0, when x is 0, that's the y-intercept. So I could, if you're asked for the y-intercept, you could use second trace value and put a 0 for x to find the y-intercept. The x-intercept is second trace 0.